So today represents obviously a very important milestone for the Institute in that we're releasing our first technology strategy. So quite a big day for us, as you might imagine, and hopefully for you too. And it's obviously important that we emphasise the economic impact of what we already do in this sector, but indeed what we aspire to do through the Institute. Because obviously this sector is a major contributor, and that success drives success in other parts of the economy as well. And I think we all should recognise that and celebrate that. So the global outlook for the sector is exciting. There are genuine opportunities for the UK to enhance its capability in this highly competitive market, provided we maintain support to that sector and act with ambition and determination. The Institute is a new approach seeking to grow from a distinctive and successful sector. It is an essential component of the Aerospace Industrial Strategy and seeks to deliver an expanding programme of technology acquisition that is linked explicitly with UK economic impact. It is one element of meeting the challenges ahead in conjunction with others, the skills, the manufacturing and supply chain initiatives that are being driven by the AGP can all make a major contribution to delivering UK broader economic agenda. So our mission is to deliver £2.1 billion worth of R&T investment into the UK and to improve the competitive position, ultimately safeguarding and enabling jobs and value creation. Aircraft are becoming ever more complex. New aircraft and upgrade opportunities are becoming harder to predict and anticipate and prepare for, and the economics of aircraft development more challenging. These factors make aerospace technology research particularly difficult to pursue. It is in this context that we have developed the technology strategy. The major challenge our mission raises is the need to link early-stage, ambitious, risky technologies with economic impact and job creation for the future. Our approach will continue to evolve as we promote debate about the vision and ambitions for the sector, allocate finite resources, and seek to catalyse change. We work closely with industry, academia, and other AGP agendas to adapt that strategy in the evolving market, building upon the foundations created so far to unlock even more value through the Institute. Technology and productivity are critical ingredients to enhancing the UK's global position in civil aerospace. This underlies the need for a holistic approach to technology strategy that recognises the needs and contributions of supply chains, universities, and other research facilities, as well as major companies and their routes to market in seeking to create maximum economic impact. The public document that we're releasing today provides a high-level view of the UK aerospace technology strategy. It is supported by more detailed papers addressing market alignment, priority value streams, and enabling technologies. We encourage you to register with our website this evening to take full advantage of that documentation, which exists for the benefit of all organisations participating in the growth of UK aerospace sector. So that's all I was going to say at the moment. I'm going to obviously pass you across to people who are much more able to give you a deep insight to what we've been doing and what we're proposing in our strategy. So first of all, I'll pass you across to our CTO, Simon.
Okay, well, good afternoon, everybody. It's great to see you all here, as Gary was saying, and it feels like we've taken a long journey together, actually. And we've covered a lot of ground in the team and also with the support, actually, of many people in the room, for which we're very grateful to put the strategy together. To deliver this mission that we're on, as Gary's explained, we're focused on helping the sector to achieve the following strategic goals over the next 15 years and beyond. So we're aiming to make the UK a global leader in civil aircraft wings, large engines, complex systems and equipment, and civil helicopters. And success in these areas will rely on ensuring the UK is providing differentiated technologies and competitive supply options in associated subsystems and components. And we must also ensure the UK is positioned to lead in all of these areas of civil aviation in future generation aircraft architectures and technologies. In February of this year, we explained the principles of our strategy to ensure that we create a coherent technology strategy and one that connects technology research with the market. In addition to developing a thorough understanding of current technologies and technology potential, it requires a view of potential future market opportunities when they may occur. And the market and technology landscape are connected through a focus on performance attributes. The priority whole aircraft, performance characteristics that the market will need, and that will drive our success. And this prioritises the technologies that we're pursuing. And the link back to the market occurs through prioritised value streams, the products and services in which the UK realises the value of its technologies and capabilities in the global aerospace market. At the heart of these principles, impact on the UK's competitiveness and economy drives overall focus. And so, in overall terms, we're just trying to create a virtuous circle, as we call it, going from the market view right through the attributes, technologies, into capabilities, products and services, and then back to the view of the market. So also shown in February, and this is a picture I hope that you're all pretty familiar with by now. We structured the strategic principles into 3 interlocking axes. So looking ahead, we've developed a view of the market. We've developed a view of the market over the next 15 years ahead, which sets the heading and the direction and opportunities for the sector. These opportunities are linked to technologies at readiness level 6 and the focus of the ATI technology development. In blue, the blue boxes, we've created or view 4 high-level value streams, and these are the streams by which we deliver products through which the industry realises value. So whole aircraft, structures, propulsion and systems. Each of these is broken down in more detail in the detailed elements of the strategy into further levels of scope to clarify specific areas of development. And intersecting and cross-cutting the value streams are 5 high-level priority technology and capability enablers. That's aerodynamics, manufacturing, materials technology, infrastructure, and processes and tools. And these are aimed at delivering the attribute performance requirements identified by the market outlook. And combined together, these elements allow us to identify the major cross-cutting themes that form the technology strategy and the specific elements that make it up. At the highest level, the strategy is focused on where the UK can capture greatest value, and this remains by some margin the single and twin aisle aircraft segments. No surprises there. The business jets market is also a significant and promising market, and one that can present opportunities to apply new technologies that could later be transferred onto applications on larger aircraft. And helicopters, whilst a relatively small segment, remains an important and vital UK capability with whole aircraft design and integration activities and a supporting UK supply chain in high-value content. To achieving the strategic goals discussed, the ATI has established a high-level set of technology priorities over 3 timeframes, referred to as secure, exploit, and position. So secure emphasises the need to ensure that some vital UK technology capabilities are secured and developed, whilst raising manufacturing productivity to ensure the UK is globally competitive. Exploit focuses on accelerating the technologies and capabilities needed to capture high probability near to mid-term opportunities and read aircraft launching in the next 5 to 15 years, as identified by the strategic framework discussed. And position is all about preparing the UK aerospace technology for long-term success to meet future market requirements with game-changing technologies. And importantly, all these begin today. Even though an application may be 15 to 20 years in the future, we need to start working on some of the key and de-risking some of the key areas of technology today. So we've identified, looking across those market opportunities, 4 major technology themes that form groupings for the programs that we're already conducting and those that we might consider conducting in the future. And they will deliver the secure, protect and position priorities outlined. So firstly, on the top left, you can see aircraft of the future. And the key elements of that are to establish a whole aircraft capability for the UK supply chain, explore the limits of conventional aircraft architectures and understand the benefits and implications of more radical architectures. Then Aerostructure of the future, that's about preparing high-efficiency technologies for new conventional aircraft, developing manufacturing technologies for low-cost, complex geometries and novel materials, and enabling more radical approaches to aircraft architecture. Propulsion of the future, that's about improving efficiency, cutting emissions, and reducing costs through complex geometries, novel materials, and new systems, and developing new propulsion architectures for step change performance in the future. And then finally, smart, connected, and more electric aircraft. That's about improving the efficiency and cost of systems and equipment, developing more intelligent, connected systems, and developing more electric aircraft architectures. So let's look at each of those areas in a bit more detail. And I do apologise for those of you at the back. Starting with aircraft of the future. So looking in the secure time frame, as we talked about, that's all about developing a whole aircraft capability, and we've already launched that now under Martin's leadership at the end of the table. And Martin's going to tell us a little bit more about that in detail towards the end of the presentation. So that's our near-term focus. And then in the exploit, the focus on the exploit timescale is exploring the limits of conventional aircraft architectures and the benefits of introducing advanced systems. How far can we push upgrades and technology insertion into conventional aircraft? Also, we'll be understanding the increases in connectivity at the air traffic management level, and the impact on that on the operation of aircraft, and much greater integration of systems, particularly use of energy across the vehicle. And then looking towards the longer term for positioning, or the position timescale, which is 2025 to 2030, that's about starting to identify opportunities for radical aircraft architectures, and then looking even longer term is exploring revolutionary airframe and power plant integration. And up here, you can see the sort of small picture on the top right hand and down at the bottom there. We're looking at really very highly integrated airframe and power plant systems, so-called boundary layer ingestion and boundary layer sort of propulsion. So very long term, but we need to start looking at those concepts now and understanding what are the key technologies to make them work. So moving on to Aerostructure of the future. In the near term, the focus is looking at smart automation for both composite and metallic component manufacture and assembly, with capability for high production rates and rapid ramp up. And sort of one of the perhaps the little takeaway lines was that apparently Airbus, I think in the UK, drill 50 million holes a year to make the wings that they make. And just imagine if you could shave a few percentage points off the efficiency of that process, what a difference it would make. We're going to be working on improving design technologies for reduced component count and lower costs, enhancing methodologies to validate aerodynamic and enhance aerodynamic and structural design together, securing critical aerodynamics capabilities. That's theoretical modelling and validation of lift and drag characteristics in wind tunnels, and developing materials and manufacturing processes. So in this exploit timeframe, we'll be integrating design, test and simulation tool sets that reduce the time and cost of design, validation, verification, industrialization. Developing technologies and techniques, including aerodynamic integration of podded, much higher bypass ratio turbofan engines, morphing wingtips and laminar flow surfaces for improved flow efficiency, and creating digitally integrated factories that are fully interconnected to maximize operational efficiency and designed as reconfigurable agile manufacturing systems, so the so-called Industry 4.0. And obviously there's a whole range of different manufacturing processes, including advanced forming, joining, and 3D printing to transform the way that we make our products. And then finally on position, In that timescale, we'll be looking at the integration of fully embedded ultra-high bypass ratio turbofans, integrating the aerodynamics of open rotor propulsion systems, and reducing vibration from helicopters. Looking at increased fuel efficiency through step change architectural concepts, such as braced high aspect ratio wings, morphing wings, active flow control, and multifunctional simplified control surfaces. And then finally, using novel materials and mechanical conversion processes for scale, economy, and efficiency in fully automated factories. Onto my home ground, which is propulsion, and that's all about, particularly for large turbofans, driving architectural change over the years. So firstly, looking at new architecture cores, and that will set the scene then for driving in much higher bypass ratio engines enabled through power transmission technology. And finally, in the position timescale and later, we may even be looking at actuating the fan blades, variable pitch fan blades, to optimize efficiency across the engine running range. And then out in the blue sky, really long term, will we effectively mechanically disconnect the propulsor from the power system, and so have electrically driven fans remote from gas turbine power systems. At the same time as working on that core architecture and overall engine architecture, we need to continue to work on low NOx combustion systems and much more effective component cooling and thermal management systems. Not forgetting that in the UK we also produce propeller systems, and so there's a lot of technology to come in making those propellers much more efficient and quieter, and reducing the cost of those systems to operate. And again, looking at the propulsion systems of helicopters, the large sort of gearbox and transmission systems, it'll be bringing through much more higher efficiency transmission systems that are cheaper to operate and generate less noise. And then finally, the smart, connected and more electric aircraft. So in the near term, we're looking to much more closely integrate power and propulsion architectures, create lighter landing gear with health management electrical actuation, and invest in power electronics components and motor drives, harsh environment electronics, components, systems and manufacturing technology. And of course, not forgetting the sort of big data underneath, working on intelligent health monitoring systems and enabling the equipment on the airframe to interact with those systems. In the medium term, in the exploit time frame, there's a lot of focus around enhanced communication systems to enable the connected aircraft. This is obviously will aid the passenger environment, so passengers will be much more able to communicate using the internet and phones whilst they're on the aircraft. But also is really important to enable connectivity between aircraft themselves and the ground, which will enable much greater awareness of where the aircraft are in time and aid planning and flight control. More electric is a big theme through the more electric aircraft and being smart and connected. And ultimately, again, we could see hybrid propulsion systems where we're using electrical power to power fans and remote generation systems from those propulsors. So those four program themes are obviously supported by the 9 technology areas. And so this sort of chart basically shows that each of those program themes is constituted really by most of each of those 9 technology areas. And the way in which we develop the strategy effectively creates a dedicated breakdown against each of those 9 areas. Taking another sort of helicopter view, what comes through strongly is that there are 2 really high-value capabilities, as we call them, that underpin most of it. Manufacturing and what we call high-value design, validate and verify. Manufacturing, obviously, we've got the high-value manufacturing catapult that's been set up to really drive through manufacturing technology. During this phase of the ATI, we want to place an increased emphasis on high-value design, validate and verify activities, because we feel they're key to actually underpin the manufacturing capability going forwards in the country. So at this point, I'd like to hand over to Cristina Garcia-Duffy, sitting here, who's Head of Technology Strategy and Integration, and she's going to take you through some of the details of how we actually put the strategy together.
Right, so you've seen an overview of the strategy, and I'm going to just show you a couple of slides on how we built this together during the past few months. So as you all know, because you've been along the way with us supporting, we've had 5 months for a common goal to develop the UK Aerospace Technology Strategy. We've held a number of meetings and various consultations with stakeholders. During March and April, the Institute hosted a number of mini-strategy workshops for our 9 value streams and enablers. In May, we used the outcomes from the mini-strategy workshops to have you all come together into a main strategy event, which was held over a day and a half of work. There were 64 companies represented at that event. In total, we've consulted with about 170 experts in the area, and that doesn't count business development or members within each of the organizations. So we just want to stress the gratitude that we have to every one of you, because we couldn't have done it with all the support from the industry. The outcome of all these consultations, meetings and workshops is a set of documents that together build the start point for our UK Aerospace Technology Strategy. So the strategy documentation comprises 11 documents. On your way out today, you will be provided with one fully public document, which you will be given in printed format. This will be also available to be downloaded on our website. Apart from the fully public strategy document, we have a set of other 10 documents, 1 on the market outlook and 9, 1 for each of the value streams and enablers. The ATI is bringing market alignment to the technology strategy to ensure a focus on commercial exploitation that will maximize the investment in the technologies. And the Institute has done some analysis on scenarios and market opportunities, which has been informed by a broad range of inputs. This document links in part at a top level with each of the 9 other individual strategy documents. The 9 technology documents align with the 9 value streams. So there is one document for each of the value streams, one for whole aircraft, propulsion, systems and structure, and one document for each of the enabling technologies, which are aerodynamics, manufacturing, materials, process and tools, and technology infrastructure. Access to the documents is restricted, but can be requested via our website. There's an application form online. People can request to get a copy via this way. We will review the applications and then we would issue you with an individual copy of the documents that you've requested. Finally, there's a set of online materials, and we are going to talk a bit about that in a minute. So for the documents, I have here an example for one of them, the whole aircraft, which is, I guess, the son of Martin. And all the documents are structured in the same way to ensure consistency. On the first page, we have included a number of terms and conditions to which you have to agree before you get the document. Going into the document, we move to the scope section. And the scope is divided, each of the areas is divided into different sub-areas. So for the whole aircraft, there's four sub-areas, and we have a front page just explaining very top level what those areas are, and then a set of individual pages explaining more about that. The point of this is to provide you with an overview of what is in and what is out within each of the value streams, because as you can see, there's a lot of interdependencies among them. So we have talked about attributes, and as we've mentioned before, these are priority whole aircraft performance characteristics that the market will need and that will drive our success. For the whole aircraft, the attributes are safety, fuel efficiency, environment, cost, passenger experience, and operational needs and flexibility. These attributes can in part be linked to the ACARE 2050 goal. Each of the individual documents outlines the whole aircraft attributes, but also what those mean in terms of the particular value stream and enabler. The next part of the document is highlighting the challenges. These challenges have been identified through exploration on the current research landscape, but also out of the consultations and the workshops with the stakeholders. Addressing the challenges, there are a number of solutions in the secure, exploit, and position timeframe and strategies. Each of these top-level solutions are then explained in more detail to the level of outlining technology developments required in order to address that particular solution. Aside from the descriptions, there's also an interdependency to the other documents. So whenever a particular challenge appears in more than one value stream or enabler, and the solutions have interdependencies, then we've highlighted those via the documents. So the last page is a collation of the current ATI portfolio of projects. So you will be able to see what's at the very top level going on in terms of projects within ATI in that particular area. So now that you have an overview of the content for each of the documents, I would encourage you to go online, please, and ask for your own copy. In terms of the online access, all of the materials are also embedded into an interactive visualization tool called SharpCloud. The access to the material is restricted and will be used to share information in future with our specialist advisory groups. We will be holding 9 webinars within the next 2 weeks, one for each of the areas, to show stakeholders how they can access the online material, and you will be able to provide us with comments and your input online so that we can have more of an interactive session. These documents are live. They are a starting point and they're our vision for the strategy, but as everything evolves, then they should evolve with time and with priorities. There's still an opportunity to join the webinars. So if you're interested, please let me know. We'll put together a list and we can send you the invite for those. And that's me. Thank you very much. At this point, I would like to hand over to Martin Schofield, who's the head of whole aircraft, to describe the planned whole aircraft activities for the Institute.
Thank you, Cristina. The next few slides will take you through the key aspects of the whole aircraft strategy as established through the process that Cristina has just described. Simon, in one of his earlier slides, touched on some of the aspects of this strategy, and I'll go through that in a little more detail. As you've seen and as you've heard from Simon and as you've heard from Cristina, the attributes are key to this, and we've talked at length about this. I just wanted to put this chart back up again to give you the context of why, as far as I'm concerned, it's actually quite important. Because collectively, those attributes define the key market, legislative and public perception drivers by which civil air vehicles will be assessed. So that's why they are so important to me. It's very important, therefore, that we find a way to quantify these attributes at both air vehicle level and also at system level. And that is one of the first key challenges that I will touch on. The air vehicles themselves that we're going to consider have been a real challenge for us, because through the workshops and everything else that we've done, every single vehicle known to man has been included as, well, that's interesting to me. No, I want that one. And so we've had to work quite hard at deciding which practically and pragmatically has to be in scope. Given what Simon said earlier on around the prime focus, inevitably, commercial airliners are absolutely in. Civil rotorcraft are absolutely in. But there are others as well, which, by the way, in, not least of which because a number of key industries within the UK supply to these and have major positions on those. So we will include things like business jets and recreational vehicles, primarily because they have a lot of contribution to the development of electrics and electronics. Unmanned air systems are in, to an extent, and I'll explain what that extent is in a second, because that's our way to get our head around the implications of increasing autonomy, both at the air vehicle level and, of course, at the air transport system level. Hybrid air vehicles are also in because clearly they have a bespoke surveillance and transport opportunity that other vehicles cannot do, and we have a very, very good example of that already in the UK. Now, the remit of the ATI is quite clear that this is civil-based, but we cannot ignore the military aerospace implications of this. And in this context, particularly for this chart here, where that will play will be where we have dual-purpose or multi-purpose vehicles. So we have to have that very much in mind as we go forward. So just to be absolutely clear and complete in here, the things that are not on that list are therefore out of scope, and those things are primarily very small unmanned air systems. So the little tiny quadricopters you see around, or someone buys you for Christmas, for example, won't be in scope. Hovercraft are not in scope. Missiles, space and suborbital vehicles are also out of scope as far as we're concerned. I talked at the beginning of this about capability, and there are two assets of this capability that I'd like to talk to you about this afternoon. The first piece of this is the modeling capability. I touched on that before in my preamble about the attributes. We need to get this modeling capability to work for two prime reasons. The first prime reason is that we need to understand what kind of technological improvements we are going to achieve if we're going to achieve the ACARI 2050 goals. The second reason is that it's part of our own assessment tool to enable us to understand the overall value that each technology proposal will actually provide. In that context, then, the capability of the modeling will include air vehicle architecture conceptual design, noise, emissions, air traffic distribution. It'll also need to include costs. So all the things that costs associated with design, development, operation, and disposal will also be in scope. Now, some of those are already available. Industry has some of those, academia has some of those. ATI, as Simon referred to, is creating some of those as well. But the key challenge here is to make sure that we can somehow, between us all, end up with a suite that covers all of those bases. The modeling will have to be done at two separate levels. Initially, we need to start at the single air vehicle level so we can understand architectural implications and also integration challenges that come with that. But ultimately, we need to wrap that up and bring it up to the system level, because without the system level, we don't actually know whether we made any benefit or not. So we need to do the both together. And in the context of this, the final piece, and bring back that chart again that you've seen a number of times for a very particular purpose, is that one of the key elements in that chart is for ATI to be able to understand what the current air vehicle competitive scenario looks like today, how is it going to change, and how does technology then inform that change? In the context of, can the market afford to buy that change? Is it giving them enough return on their investment to make it affordable? The second thing, of course, is there may well be some legislative drivers as well within this context. So that's why ATI is going to acquire that capability all of its own. So, next piece then is breadth of capability, and within that, there are three pieces. The first is integration. We've heard there's a move to greater integration of the air vehicle, and it's linking up systems and components that previously probably were standalone. So this implies that many of the components that are provided by the supply chain that are key to these systems are now going to be more integrated, and so there needs to be a greater need to have a more comprehensive integration capability across the supply chain than we've had today. Now, this is a split responsibility, I think. Part of it will belong within my group, but also part of it will belong within the technology infrastructure. We'll have to work closely to achieve that. The second is education. In the past, we've had many airframe manufacturers who understood their air vehicles. Today, we have very few. It's very difficult for most levels of the supply chain to be able to understand how the changes they propose will affect other parts of the air vehicle. So the idea that we've had is to create a whole aircraft chief designs of the future program that provides all levels of the supply chain with an appropriate level of understanding of the complete air vehicle within some of their key individuals. The third piece then is assessment. And we've talked a little bit about the models in the assessment. What I actually mean by that in this context is that if the UK PLC is to acquire that assessment capability, it's only right that that capability is then shared across the whole supply chain so that they are informed about the impact of their technology, because firstly, that means that they are better able to make their own internal business judgments, they're better able to make sound business decisions, sound business cases on the back of that information. But secondly, of course, they'll also be able to put better constructed proposals together because it will be backed by the information in that kind of analysis. My final slide then is safety and certification. There's a whole series of broad system-wide aspects that we've discussed at various meetings and various sessions that come under this category. The first one is security. We all now know how increasingly reliant air vehicles are on data for their systems themselves, but also data for their operations. And as we move towards these integrated air vehicles, the need for increased security will become more and more acute to prevent it being used against us for deliberate and malicious interference. The second piece is human factors. There's been a lot of talk of late about the man-machine interface, particularly in relation to flight deck and well-publicized incidents. So there's a need to push human factors methodologies to better understand that, to help us get to grips with air vehicle autonomy. I've talked about the flight deck example. The other example would, of course, be as we continue to push for unmanned air systems within the civil aerospace sector. The third piece is the certification process. The industry will benefit from help to reduce the timescale and cost of the certification process that ultimately brings any new technology to the market. At the same time, the improvement potential for each technology needs to be maximized. Clearly, though, there is an important caveat within that safety has to be paramount. And finally, the air traffic system development. Simon's touched on this a little bit, but clearly levels of traffic are increasing. We're putting more throughput through the existing air traffic network. So there is a huge need there to help us develop the technologies at air vehicle level, perhaps, at air traffic management level, perhaps, that will enable us to get the maximum out of the air traffic system that we have today and improve them, but of course, more importantly, make them robust for the future when we could end up with either a mixed conventional aircraft, unmanned air system, airspace, or even a totally unmanned airspace. Okay, so that was a quick overview of the whole aircraft strategy. Thank you very much for listening, and I'll hand back to Simon now for his concluding remarks.
Thanks very much, Martin. So just before we go on to the next steps, is just to remind you a little bit of what Cristina said about how you can access the technology strategy. So before you go today, you should get a printed copy of what we call the public document. So that's about 20, 30 pages long, and it's kind of a high-level summary of the strategy. Behind that are 10 separate documents, and they're what we call the restricted documents, and we only call them restricted because we're trying to largely restrict them to the UK technology community and people working in UK companies and people who influence what happens in those UK companies. And for that reason, we want to make sure that each copy that you download, we can identify it and you've registered that you've got that copy and you understand the conditions associated with it. That's all it is, and you'll be able to download those copies. So there's a bit of process around it, but we thought it was important. So yes, there will be 10 of those restricted documents. So you can imagine the whole lot, if you added it together, is quite a lot of work, and that's the culmination of several months and all the workshop sessions we've run. So I encourage you, to get on the internet once you go away and to start registering to do that. Okay, so the next major step then after getting our strategy out is the working groups, our specialist advisory groups. And if you're at the workshop session in May, we told you what the steps were about that. So it's kind of just reiterating what we told you there. We have already started what we call the Technology Advisory Group, which is our senior level technical steering group. That was launched in February of this year. And the specialist advisory groups, we will start to form those effectively from now over the summer. And we will plan, and those dates will be advised to start have the first round of meetings of those specialist advisory groups in September of this year. So there are 9 specialist advisory groups, one to represent each of the 9 areas of the strategy. So if you recall those restricted reports, there's 10. One of them does the market strategy. The other 9, we've got one for each of the technology areas. That corresponds to the specialist advisory groups. And if you think about it, each of those papers, because it's got quite a detailed scope section in, defines the scope of each of those working groups. So that's a really important point. So we will be opening the registration of interest to join those groups in July, very shortly in the next few days. Again, that's a kind of an internet-based sign-up process. You will also get a personal invite by email. If you've been to any of our workshops, you've come today, you're on our mailing list, you'll get an invite to apply to the specialist advisory groups. And also that will be in our regular mail shot, our news document. The details on that will be on our website. We will start to just notify and get back in touch with people during August, and obviously we will be advising the dates for those meetings. And we will start the advisory group meetings in September. Just remembering the members of those groups, it is the community of people who are actually actively engaged in doing research, or people that are engaged in funding research. So it's quite simple, and I think that's pretty much everyone in the room fits that criteria. So any questions? Gentleman here. Perhaps you can just say out your name so that it'll appear on the film.
Yeah, Roger Hazelden from TRW Connect.
Yeah.
I'm involved in various of the existing NTC activities.
Yes.
And I know that from talking to a number of people, there's some concern that the existing NTCs don't map directly to the new strategy you're putting, particularly areas like the health management and prognostics, the autonomous systems and the electrical power systems and things like that.
Yes.
And I know that there is a concern in the community of those NTCs that in moving to this new specialist advisory group structure, that some of the very good coordination and things like that is going on, and the good networking and linking together in big and small companies, that some of that might be lost. Can you comment on how that's going to be managed?
Well, I don't think that will be the case. And if you looked, we've effectively created a broader systems advisory group, which I would expect pretty much all of those to sit within. That will be Mark Scully's job. I don't know if Mark sat at the back. Perhaps you want to stand up. Do you know Mark Scully? Yes. So Mark is heading up technology for systems and propulsion. And one of the ways in which we envisaged doing that we see that would be actually quite a big group of people, and that we'll probably split the meetings into two parts. So if you looked at a typical advisory group meeting, you might have half the day where you've got a plenary session, and then half the day where you can split off into separate interest groups. So you can still have that special interest focus. But we felt the important thing was to bring together the systems community as a whole, rather than in, never getting together and just meeting in the little sort of individual interest groups. So that's the way we see it working. And obviously we'll take a rain check as we're, developing that advisory group system to check that we still do have those areas being covered in the right level of detail. Okay, thank you. Any more questions? No? There's a hand vaguely going up there.
So,
Dan.
So Dan Kells from the National Composites Centre.
Yeah.
So you've actually talked about the catapults being very important in the
Yes.
delivery, I guess, particularly of the manufacturing
Yes.
strategy. Unfortunately, the funding rules make it quite difficult for the catapults to be taken up as partners in these projects, and we tend to end up as being subcontractors.
Yes.
Have you got any comments on that?
Well, obviously that's part of the tenets of the ATI when it was set up. The mandate effectively was that our programs would be industry-led. And so each of our programs needs an industry leader. And in overall terms, we are trying to get to 50-50 funding. So that means that you're quite right. That does create some difficulties. But I think we can work through it. And, there are a number, as you know, a number of programs up and running where the manufacturing catapult centres are, big players and partners in that program. But right now that was the way the ATI has been set up, and we need to work with that.
Ken Young, Rolls-Royce. You mentioned the webinars. I wonder if you could tell us a little bit more about what we should expect from those.
Yes, what we promised at the workshop in May was that for the people who were at the workshop, we would organise a webinar to give feedback on how we'd used the output from that workshop. So that's specifically the purpose. And it also goes through, gives people a bit of a driving lesson on the online material that's been created to accompany the strategy documents. And we'll be using that, I think, quite extensively going forward to continue to populate with information that we generate from the working group. So it will become, I think, quite a very accessible and useful resource for technologists and so on working in the field. So that that's what it'll be, and obviously will enable people to ask a few more detailed questions on the details of the technology strategy, the documents themselves, answer any of the questions that people have. So yeah, it's basically trying to sort of do what we promised to do at the workshop on the 5th of May.